Kuzambula. Welcome to Bhutan e-learning program. I am Uin Kyalzang from Gelifu Middle Secondary School. Today's lesson is intended for Key Stage 4 learners, that is for classes 9 and 10. And the topic for our discussion today is operations on linear polynomials. So let's begin. Well, the objectives for our lesson today is to identify the type of polynomials based on the order of degree and the number of terms. Model with algebra tiles to add and subtract polynomials using zero principle. We will add and subtract symbolically. We'll also use model area with algebra tiles to multiply and divide polynomials. And finally, we'll multiply and divide symbolically. So, let's get started. After taking a look at the addition and subtraction of polynomials, both using algebra tiles and symbolically, we shall now move on to multiplying polynomials using algebra tiles. To multiply two polynomials of degree 1, we use the area model, whereby we create a rectangle whose dimensions are the two polynomials to be multiplied, and the area of the rectangle in the tiles represents the product. In a way, the very basic understanding of area model is that we have length times width equals to area. The length and the width, which are the two dimensions, are representing the factors, and the product will be given by the area of the rectangular shape that we create. Let us take a look at one of the examples here. So multiplying polynomials using algebra tiles. Let the question be, model the given multiplication and find the product. We have the first polynomial 2x minus 1 multiplied by the second polynomial 3x plus 2. These two polynomials which are multiplied, what would they represent? Yes, they represent the dimension. So we can consider them as one of them as the length and one of them as the width. And what will give the product? Yes, it is the area. So the product is generated by the area we get. Okay, so let's begin arranging. So I take 2x minus 1. So I take it on the at the vertical dimension of the rectangle. So I take 2x. So 2x tiles arranged vertically, and then for minus 1, I keep a negative unit tile. The other polynomial, 3x plus 2, I take its dimensions using the tiles and arrange it horizontally. So I have 3x, so 3x tiles, and we have plus 2. So to represent that, I will use two positive unit tiles. Now that I have the framework of the dimensions, I'm going to create a rectangle to match the frame. So I draw the rectangle, and then what is the area of the tiles that I get here? So I get how many x squared tiles? I get 1, 2, 3, 4, 5, 6. I get 6 x squared tiles. And how many x tiles? Well, I have 4 positive x tiles and 3 negative x tiles. If you still remember the zero pair or the zero property, you shall remember that they cancel out each other. So negative 3x will cancel out the 3 positive x tiles, and we'll be left with only 1 positive x tile. And finally, we still have minus 2 unit tiles there, so we take them up. So the area, which is representing the product, we have 6x squared plus x minus 2. We will now look at multiplying polynomials symbolically. When we multiply two polynomials, each term in the first polynomial is multiplied by each term in the second polynomial. And then the like terms are combined. For example, let us take a very general example of two polynomials being multiplied here. For the first, we have ax plus b times the second polynomial, cx plus d. What do we do here? we take the first term of the first polynomial and we multiply with each and every term on the second polynomial. This is again in accordance to the distributive property. Similarly, we take the second term of the first polynomial and we multiply with each and every term in the second polynomial. So while multiplying, let us see what do we get. We have, when we multiply the first term with the first term of the second polynomial, we have acx squared. Multiplying first term with the second term of the second polynomial, we have adx. Multiplying the second term of the first polynomial with the first term, we get bcx. And multiplying the second term of the first polynomial and the second term, we get bd. Now, we have acx squared plus adx plus bcx plus bd. Now, before we proceed, we look for any like terms. We do have some like terms there. If you spot it out, in the second and the third term, they are both having the variable x. So, what do? We extract the x variable x outside and we put the coefficients together within the brackets. So lastly, we have acx squared plus, within brackets, the two coefficients, ad plus bc with the variable x, and then the finally constant value, that is bd. Using the same exact idea that we just discussed, let us multiply polynomials symbolically in the question given. We have 2x minus 1 times 3x plus 2. So we begin by taking each and every term from the first polynomial and multiplying with each term of the second polynomial. So the first term, 2x, goes to the first term in the second element, second polynomial. We have 2x times 3x, 6x squared. Similarly, the first term going to the second term, we have 2x times 2, we have 4x. And both are positive, so we are again having plus 4x. Now it's time to operate with the second term in the first polynomial. Negative 1 goes to 3x. We have 1 times 3x. We have 3x. But since 1 is negative and 3x positive, we come out with the negative 3x. And again, taking the second term and going to the second term of the second polynomial, we have minus 1 times plus 2. We get negative 2. So we have 6x squared plus 4x minus 3x minus 2. What do we do next? Yes, we look for the like terms. So here, the second and the third term with x variable. So we extract the x variable outside, put the coefficients together in the bracket, and we have 6x squared plus 4 minus 3x minus 2. And when you evaluate the coefficients, we are left with 6x squared plus x minus 2, which is our result. Now that we have seen how to multiply polynomials, both using the algebra tiles and doing it symbolically, let us now go towards dividing polynomials. And first of all, we shall divide the polynomials using algebra tiles. Now, when we divide polynomials, just like in multiplication, we can use the tiles and the area model. The area of the rectangle here represents the dividend. And one of the side lengths is the divisor, which is given. The other side length, which we find out, is the quotient. So basically, the area divided by the side length gives the unknown side length. Here, area is the dividend. The known side length, which we divide, is the divisor. And the unknown side length is the quotient. Using the understanding of area model in dividing the polynomials with our algebra tiles, let us take a look in this example. Use algebra tile area model to help you divide the first polynomial, 6x squared plus 7x minus 3 divided by 3x minus 1. So here the dividend is, what is the dividend here? It's 6x squared plus 7x minus 3. And what is the divisor here? It is 3x minus 1. Now let us think these polynomials in the scenario of our area model. So what does the dividend represent? Dividend represents the area. So these are the area, these are the tiles that we have to use in order to create our rectangle. And do we have any side lengths here? What does the divisor represent? Yes, it represents one of the side lengths, and here it is 3x minus 1. So let us put the dimension of the side length here. So we have 3x minus 1. So I arrange it horizontally, representing one of the dimension. So 3 positive x tiles and 1 negative unit tile. Okay, now I use the area now. I have to start picking up those tiles and placing it so that I get our rectangle. Okay, so 6x square. So I have 6x square tiles. So let us start placing them. So we have 1, 2, 3. Now I cannot go horizontally. I have to take it down. So I have continuing 4, 5, 6. Okay, so it looks good so far because we are still continuing with the rectangle shape here. We have managed it so far. Going with the second item there in the area, dividend, we have plus 7x. So we have positive 7x tiles. So again, arranging the x tiles here. I cannot put it vertically under the negative 1 unit tile because it is negative. It should be red. However, we have blue ones. So we take it down under our x square tiles and arranging them. We have 1, 2, 3, 4, 5, 6, and one more, 7. It doesn't look complete. It still needs some work, but we'll wait for some time. We'll go with the other tile that we have in the dividend. We have minus 3. That means we have 3 unit tiles, all of them negative, so red. But how do we place them? Some of my students, they have a problem here. They arrange these unit tiles along the x-axis, side by side, which is incorrect because we do not know exact comparison between the unit tiles and the x. Remember, the measurement of x is unknown, so we cannot place them alongside the x dimension. So we place it along its own measurement, that is along its unit measurement. So we place it along the unit measurements, and we have these 3 tiles here. Okay, so our rectangle still seems incomplete, and we could use some tiles. Well, what are some of the tiles we could use? We could definitely make use of some x tiles, but we have nothing. So we have 0. So whenever we think of having nothing, we can think of our 0 principle. So which pair or which 0 pair would you like to bring up in order to fill this up? We are missing x tiles, so it would be perfect for us to use the 0 pairs of x tiles. So I have a pair of x tiles, 0 pairs. So I will take positive x tile and negative x tile, place them alternatively, the red one under the negative unit dimension and the blue one horizontally with under the x tile. Okay, still we need another pair here. So going back to 0 principle, I'll bring back another 0 pair of x tile. Again, the red x tile along the negative unit dimension and the positive horizontally under the x tile. Now it seems that our rectangle looks perfect. We already have the given dimension. Now, what would be our quotient? If you remember the area model, our quotient is represented by the unknown side. So let us measure the other side length, the unknown side length. If you look at the vertical side length, we have 2 x tiles and we have 3 positive unit tiles. So together they are 2x and plus 3. So our dimension here of the unknown side is 2x plus 3, which gives our quotient. Let us now look at dividing polynomials symbolically. Here we are going to use the long division method. So we have an example here. It says divide the 6x square plus 7x minus 3. It is divided by another polynomial, that is 3x minus 1. This division may look heavy because we have a lot of variables and terms here, but the same idea is something that we have been doing for so many years. Let me take a very simple example. 234 divided by 3. Now, if you look at this division, it looks very simple comparing to what we have in our hand right now. However, the process is exactly the same. Let us see how. How would you go about this very simple division here? The first thing you're going to do is you're going to represent it 234 divided by 3. This is the representation that you're going to use. We're going to use the same representation for our polynomials here. So the dividend here is 6x squared plus 7x minus 3, and this is being divided by our divisor here, 3x minus 1. The only thing you need to be careful here when we divide polynomials is to check that whether the polynomial is in the order of decreasing power of the variable, so that the first term is always having the highest degree of the variable and it goes decreasing towards right. So that is the only important thing you have to take care. Here it looks fine. The first term has the highest power, the second term has the lower, and then it goes on. So it's fine. Now how do we start? Again, let us go to our simple example here. This will show us our way. This will guide us through the process of division here. So what do we do here? Here, when we divide 234 by 3, we think of a number which when multiplied gives a number as close as possible to 23. So in this example, we could think of number 7. So 3 times 7 would give us 21, which is as close as 23. Similarly, we come here and then we think of number here. Now, when we think of the number, we look at only the first term here. The first term is 3x. Now, we have to think of 3x should be multiplied to which number so that we get as close or even equal to the first term of the dividend, 6x squared. To do this, let us go to our thinking corner. So 3x times what would give you 6x squared? Let us think about the coefficient here. 3 times what coefficient would give you a coefficient of 6? Very simple, a 2. So 3 times 2 would give a coefficient of 6. The variable we have is only x, but we have to get x squared. So with what would you multiply? Yes, we would multiply with another x. So now if we multiply, we get 3x times 2x, we'll get 6x squared. So the variable we need is 2x. So 2x. Now we have got the number. But we have to be very careful here when we move on, because if you go and look at the simple example here, when we get the number here, what do? We do 3 times 7, as earlier we wrote it, 21. However, in this case, we take 2x and we multiply. Do you think we multiply with only 3x? No, because we have two terms here. We have two terms here, they're together. So we go and multiply 2x with the whole divisor, that is 3x minus 1. So we multiply with the divisor, which has two terms. So what we are going to get? We're going to get 2x times 3x, we're going to get 6x squared, and 2x times 1, 2x, positive, negative, negative. So we are going to get 6x squared minus 2x. So we have 6x squared minus 2x. I hope everyone is with me through this till here. Now what do we do next? Again, we go towards our guide. So what happens after this in this simple example? We have 23 and 21. Yes, our natural instinct says we have to subtract it. So we get the difference 2. Let's wait here and take the same idea to our situation here with the polynomials. We subtract. So in the first term, both are 6x squared and 6x squared. We get nothing here, a very clean space here. Now we take a look at here. We have positive 7x minus negative minus 2x. Let me put it here in your thinking space. We have 7x minus negative 2x. It is subtraction of integers. So what do? We add the opposite. So when we add the opposite, we get 7x plus, instead of negative 2x, we get positive 2x. So 7x plus 2x, we get 9x. So we have a 9x here. Okay, take a break. Let's go back to our simple example. See what happens now. Yes, we bring back the last digit here, 4. Same thing, coming back to our example, we bring the last term here, we bring it 3, but please be very careful with the negative sign here. So we bring along the negative sign, so we have 9x minus 3. Okay, what happens? What does our guide tell? Okay, so 24. Again, we think of the number, which is very simple. I think we are done here now. So 3 times 8 is 24. And we are done. See? The exact same thing is going to be done here. So 3x times what? Again, we follow the same thing here. We consider the first term of the divisor and the first term in the dividend. So 3x times what will give you 9x? Go to our thinking box here. 3x times what will give you 9x? We have already we can see that the x term is already there. We just need to take care of the coefficient. So 3x times what will give you 9x? It's going to be 3. So we are going to multiply with 3. But wait, should it be a positive 3 or negative 3? If you look in our work here, it's going to be positive 3, because we have a positive 9 here. So 3x times 3 is 9x, and if it is positive, we are left with a positive 9x. Again, when you write the multiplication here, we have to be careful, because we multiply the number 3 with both the term, because our divisor here consists of 2 terms. So when you multiply 3x minus 1 multiplied by 3, we multiply both the terms, distributive property, we have 9x and minus 3. So we get 9x minus 3. And just like our simple example given, we take down their difference. We have the same polynomials subtracted. So we are done. We don't have any remainders. So the final quotient that we are left with using our long division method is 2x plus 3. So which is the answer and the quotient to our division. Now that we have come to the end of this lesson, I have a set of tasks for you to practice the skills that we have learned. So simplify the given polynomial operations by both using the tiles and doing it symbolically. I have a set of questions. The first one, multiplication task. Second is a division question. Remember, you have to do these problems both by using algebra tiles and also symbolically. This is the end of our lesson today. Hope you enjoyed this session. I look forward to seeing you in the future classes. Thank you. Keep exploring and keep learning.